All right, guys, so today we are going over the review sheet. We're going over the problems on the review sheet, and your first part of the test is tomorrow. So, are there questions on problems 1 or 2? Questions on how to do problem 1 or 2? Question on 1 or 2? 1. If we look at problem number 1, 6a cubed b squared minus 36ab squared plus 71a squared b squared, the first thing we need to look for is a greatest common factor amongst these three terms. Now we do notice that all three do have a in common, so we can factor out an a. And they also all three have a b term. Now with our a term, a cubed, a, and a squared, the most that we can pull out of all three is just a. Because we can pull one a out of a cubed, we can pull one a out of just a, and we can pull one a out of a squared. Now our b term, it is also in common all three. We have b squared, and b squared, so we can factor out a b squared. Now the other thing to consider is a number, seeing if there's a number in common with 6, 36, and 71. 6 and 36 have a common factor of 6, but we need to see if 71 has any common factors with 6. 71 is not divisible by 6. Well, we can try 3 and 2. So there is no common number with 6, 36, and 71, because 71 is actually possibly prime. So the only thing we can factor out of these three terms is ab squared. So we'll still have the 6 from our first term. A cubed, I'm going to remove 1 from it, and it's going to give me a squared. And the b squared will factor out completely. Then we'll have minus. We'll still have the 36. The a and b squared will both factor out completely, leaving me with just 36. Plus 71. Now, we can factor an a out of a squared, leaving us with a. And then the b squared will factor out completely. Now at this point here, it might be helpful, especially factoring from here, to rewrite the quadratic in standard form. Now, interestingly enough, this is actually as far as it goes. 6a squared plus 71a minus 36 does not factor farther than this here. There's only going to be 3 questions on the test, 1 on part 1, 2 on part 2, that just have a greatest common factor. The rest are going to have our multiple sets of parentheses go through our normal steps. Only 3 of them on the test, 1 on part 1, 2 on part 2 is just going to have a greatest common factor. Well, we could go through our normal factoring steps. It ends up being that we're not going to be able to multiply together to get the middle term. Now, one of the ways we can check and make sure it doesn't factor is using the square root of b squared minus 4ac. This is really giving us a hint at what the answers are. So 71 squared minus 4 square root. 71 squared minus 4 times 6 times negative 36. And this here is telling me that my solutions are irrational. So if it has irrational solutions, it means it's not going to factor. So the square root of b squared minus 4ac is just a way to check, hey, the factors don't seem to be working. Will it factor farther? This one here won't. Questions on number 2? Number 2, we have 2 things being subtracted, so there's a good chance it's a sum or a difference of perfect squares or a difference of perfect cubes. X squared, b squared, hinting at difference of perfect squares. Our difference of perfect square formula is a squared minus b squared, which factors to a plus b times a minus b. where a and b are our terms multiplied together to give us the first and third term, second term here. So to find a and b, well, we need to see what times itself gives us 36x squared. Well, 6 times 6 is 36, and x times x is x squared. So the number of times itself to give us 36x squared is 6x. And we also need to see what times itself gives us 49b squared. Well, the b squared part is going to be b. Now to find 49, what times itself is 49? We can do the square root of 49, which is 7. We can just say 7. Telling us that a in this case is 6x. B is 7b. So it's going to factor to a plus b times a minus b, which would be 6x plus 7b times 6x minus 7b. And that's it. Questions on those here? Questions on 2 or 3? Either one of these that we want to see work. We feel good with these two. Which one? 3. A squared plus 4a plus 4. Again, we're going to factor this. We don't have a difference of perfect squares, some are difference of perfect cubes, so we're going to go through our main steps. First, we're going to look for a greatest common factor amongst these 3 terms. There's not one. So we move on to our 2 sets of parentheses with 3 spaces. Now we want to find the signs. If the third term is positive, the signs are the same and match the sign of the middle term. And the third term is indeed positive, so it tells us the signs are the same. And they're going to both be positive because the middle term is positive. If that third term is negative, the signs are opposite. Now we need to look at the factors of the first and third terms. Well, our factors of a squared, the only set of factors we have are a times a. Now our factors of 4 are 1 and 4 or 2 and 2. Which set of factors do we want to try first? 2 and 2. And again, we do want to check and make sure we do get the correct middle term. A times 2 is positive 2a. 2 times a is also positive 2a. And 2a plus 2a gives us 4a, which is indeed the middle term that we wanted. So a plus 2 times a plus 2 are the correct factors for this here. We could also say that it's a plus 2 squared. Either one works. Just have to have one or the other. Questions on number 3? All right. Yes. 64x squared minus 1. Now this does look like it's a possible difference of perfect squares because we only have 2 terms that are being subtracted. And it will be if these 2 can be rewritten as something times itself if they're both perfect squares. Now, the reason I say difference of perfect squares and not difference of perfect cubes is kind of the hint that they gave us with the x squared. Because what times itself is x squared? Well, that would be x. If it had been x cubed, or power bigger than 2, we might be looking at cubes. Now we need to see what times itself is 64, and that would be 8. We can either know that 8 times 8 is 64, or if we take the square root of 64, it will tell us that it is indeed 8. Now we need to figure out what times itself is 1. 1. So according to our difference of perfect squares formula, a plus b, well, a is 8x, b is 1. A minus B would be 8x minus 1. And that's it. We can go on and do number 7 while we're here. A cubed plus 1. A cubed tell me it's not a sum. We do have a sum. A cubed tell me there's a good chance it's a sum of 2 cubes. Two things being added together, we do have a to the third. So there's a good chance we can rewrite it in that a cubed plus b cubed form, which factors to a plus b times a squared minus ab plus b squared. Straight from the theorem. But we need to figure out what goes in the place of a and b, because we need to figure out what times itself 3 times is a cubed, which would be a. What times itself 3 times is 1. 1. So in our first set of parentheses, a plus b, well, a is just going to be a, and b is going to be 1. In our bigger set of parentheses, our first spot is going to be a squared. Well, we're going to replace the a with a, actually just giving us a squared. Minus a times b. Replace the a with a, we replace the b with 1. Plus b squared, well, that's going to become 1 squared. So all we've done is what? Replace every a with a and replace every b with 1. Now we need to simplify. In our first set of parentheses, the a plus 1 becomes, well, a plus 1. We just drop the parentheses and we're good there. Our first spot here, a squared, is going to become a squared. If there's a number with the a, there's a number with that variable, you have to square them both. So if it's 2a, it's going to become 4a squared. Now the middle term, a times 1 is a. Plus, what is 1 squared? 1. So a cubed plus 1 is going to become a plus 1 times a squared minus a plus 1. Doesn't matter if the first term or the second term is negative, formula takes care of signs. We just need to see what a and b, what's taking the place of a and b, plug it in for a and b, simplify. Questions on number 8 or 7? We feel good with this here. Questions on 8, 9, 10, or 11? Number 10 is not factorable. There's not going to be a not factorable on the test. Because even the ones that we factor out a greatest common factor only still is factorable because we can factor out a greatest common factor. There's not going to be one on the test that's just straight not factorable. 3 of them are just greatest common factor. The rest we can use our methods, getting up with 2 sets of parentheses to solve it. There's not going to be one like 10 where we cannot do anything. So, questions on 8, 9, 11. 8. 8x squared minus 72. We have 2 terms being subtracted, and we do have an x squared, so it's telling me there's a chance it's a difference of perfect squares. Now we need to see what times itself is 8. So we can go second square root 8. We get 2 squares of 2. So there is not a perfect, 8's not a perfect square. Is there a greatest common factor between 8 and 72? And it actually kind of gave us a hint with taking the square root of it. If I take the square root of 72, we get what? 6 square roots of? What's in common with both of those? Square root of 2, yes? So most likely, they both have a greatest common factor of 2. And I divide 8 by 2. Yes, and we get 4x squared. 72 divided by 2 is 36, yes? Now I said a minute ago that the calculator gave us a hint at what the numbers are, especially that square root of 2. Well, you don't have to write it down at this point. It's our difference of perfect squares, a plus b times a minus b, yes? Well, what times itself is 4x squared? It's going to be 2x, yes? Well, what did we find when we took the square root of 8? 2 square roots of 2. The square root of 2 term is what's the greatest common factor. Our whole 2 is what times itself. What times itself is 36. 6 squared is 2. It kind of gave us a hint. Now it's going to factor to a plus b times a minus b, yes? Well, what's a? Yeah, 2x plus 6. B is, and then the second one is 2x minus 6. Yes? And yes, it can be factored farther. Because this is factored form, yes? And the reason I say factored farther, is there a common factor between 2x and 6? 2, isn't it? Can 2 go into 2 and 6? Yeah. So there is a greatest common factor of 2. How about here? So we have the 2 that we factored out first. From our first set of parentheses, we also factored out of a 2. Second set of parentheses, we also factored out a 2. We're just dividing it out. When we divide that common factor out, we move to the front. 2x divided by 2 is x plus what? 3. 2x divided by 2 is x minus 3. What's 2 times 2 times 2? 2 times 2 is 4. 4 times 2 is 8, yes? So that is the final answer. Let's see here. (72) is divisible by 8, so we could have factored that out to begin with. Even if we don't see it, we got it to something that did work. We can go from there. So our first division was this 2 here. I noticed when we got to the end, 4x squared minus 36 factors, difference of perfect squares. Because 4x squared is 2x times 2x. 36 is 6 times 6, yes? So we can do difference perfect squares. The only reason I needed to do this again was, well, I saw 2x and 6. 2x and 6 do have a common factor of 2. We can pull it out. If you get here, that's great. Because at this point, you're only losing a point out of the total of 5 or 4 points per question. It's not full credit off. Because you're only missing that last simplifying. But if you get here, great. If you notice, oh, it can go one more time, we just pull it out and multiply those common factors together and simplify. Does that make sense? Yes. What times itself is 4x squared? That's where we got that, 2x squared. Because we're getting it into the form of a squared minus b squared. Because if I can get it in a squared minus b squared, I know a has to be 2x. I know b has to be 6. It just happened that there's another common factor that we could take out farther. Does that make sense? Because that's all that was happening. If you notice that there's a greatest common factor of 8, you'd still get to 8 times x plus 3 times x minus 3. It just jumps straight to it. That makes sense? Okay. Questions on 9 or 11? I'll look at 11. 49x to the 4th plus 343x cubed plus 7x squared. There is a greatest common factor across all three. They all three have a variable in common, x, and the smallest exponent attached to that x is 2. So that's kind of telling me that x squared is a common factor across all three. 49, 343, and 7. We need to see if there's a number that goes into all three. What's one number that could work? 7, because 7's prime. So if there's going to be a number, 49 has to divide by 7, and it does. And 343 has to divide by 7, and it does. So I can factor out a 7. Now, if I factor 7 out of 49, 49 divided by 7 is 7. And if I factor the x squared, I divide x to the 4th by x squared. We take 2 away, we get x squared. Plus 343 divided by 7, 49, and we have x because we took 2 away. Plus, if I 1, 7x squared divided by 7x squared, if we factor it out, it's going to reduce to 1. Two sets of parentheses with 3 spaces. And if you're not sure, especially this doesn't look like it's factoring, square root of b squared minus 4ac. Plug it in, b is 49 minus 4 times 7 times 1. See if you get a nice number. If it still has a radical, has a non-repeating decimal, domain error, it's not going to factor from there. Here, since the third term is positive, so the signs are the same and match the sign of the middle term, which is also plus, so we'd have plus and plus. Factors of 7x squared. 1 and 7, and then we'd have our x and x. Factors of 1 are 1 and 1, yes? So we can check the middle term. 7x times 1 is 7x. 1 times x is x. 7x plus x is 8x. Is that the middle term we wanted? Flipping the 1 and 1 is going to do nothing. Flipping the 1 and 7, nothing. Do I have any other factors? No. So that's it. Now I can check it and make sure. Our square root of b squared minus 4 times 7 times 1, non-repeating, non-terminating decimal. So it's also telling us it doesn't work. Yep. If that had been plus 7 instead of, no, that still wouldn't work. Yeah, it had to have been 50, but we get this here. Questions on number 11? Questions on 12, 13, 14, or 15? One of those that y'all want to see work. 13. 375a cubed plus 192b cubed. The a cubed and b cubed kind of tell me that there's possibility of a sum or difference of 2 cubes, because a cubed is a times itself 3 times. Same with b. And since it's plus, it's going to be our sum. of 2 cubes. So we need to see if there's a number times itself 3 times, it's 375. And it tells us that there is not one. And we'll get a similar thing with 192. So the next thing I'm looking for is the greatest common factor between these two terms. Now 375 and 192 are both big numbers, so I'm going to start small. 2. 2 does not divide, or 375 does not divide by 2, because it's not an even number. So the next number we can go is 3. 375 divided by 3, 125. 192 divided by 3 is 64. Now we can make sure that these are the right numbers, because if I can take the cube root of 125, I can. If I can take the cube root of 64, okay. So the greatest common factor had to be 3. So the first thing we're going to do is factor out a 3. So if we factor that greatest common factor out, we get 3 times 125a cubed plus 64b cubed. Now from here we can figure out what a and b are that we need to plug into our general form for a cubed plus b cubed. As we just saw, 5 times itself 3 times is 125. A times itself 3 times is a cubed. So 5a times itself 3 times is 125a cubed. So it's going to take the place of a in all 3 spots. 64, we figured out, was 4. So 4b times itself 3 times. 4b cubed is 64b cubed. Questions on how we got to this here? So our a plus b, well, a is 5a, plus our b term, which it incidentally is 4b. Now a squared is going to become 5a squared. We're going to have to square both terms. Minus a times b, well, our a term is 5a. Our b term is 4b. Plus b squared, well, that would be 4b squared. Questions on how we got to this point here? Last thing we'll need to do is to simplify this here. We still have the 3. Our 5a plus 4b is, well, 5a plus 4b. 5a squared, 5 squared, 5 times 5 is 25. A times a is a squared. Minus 5a times 4b, 5 times 4 is 20. A times b is ab. Plus b squared, 4 squared is 16. B squared is b squared. Questions? Something didn't make sense? Okay. Not what I wanted. Better? At any point I start using a color you can't see, tell me. For the a and b, or the first and third term, yes. Because just based off the formula, it's a squared. In this case, a squared minus ab plus b squared. So we're going to square both of those terms. Because for here, a, what's taking place of a is 5a. So we're saying that whole term is being squared. We're saying 5a times 5a. So our 5 times 5 is 25. A times a is a squared. Same with b. Does that make sense? Now, if it's just a number, we'll still do the same method, same operation, but if it's just had been 4 squared, not 4b squared, it's going to be 16. We've simplified the square. Variables still have the square because we are saying it's b times itself, but because it's not a number, it hasn't been simplified to just a number. We have to leave it there, signifying that b is still being multiplied by itself. Does that make sense? Because we can't just say b, because b and b squared are 2 different values based off what the value of b is. Any other questions on 12, 13, or 14, or 15? 15. A squared minus a minus 6. Well, not a sum or difference of perfect cubes, not a difference of perfect squares, so it's got to be normal factoring. A squared a negative 6, or a squared a and 6. There is no common factor amongst those 3 terms, so we're to 2 sets of parentheses with 3 spaces. Third term. If the third term is positive, the signs are the same and match the sign of the middle term. Here, the third term is negative. If the third term is negative, the signs are opposite. One's plus, one's minus. Factors of a squared are? Well, it's just a and a, yes? Only set of factors we have. Now, factors of 6. 1 and 6, 2 and 3. Which one do we want to try first? 2 and 3. Where do you want to put the 2, with the plus or minus? Plus, 3 with the minus. Last thing we want to do is check. Make sure we got the correct middle term. A times negative 3 is going to be negative 3a. 2 times a is going to be positive 2a. Negative 3a plus 2a, negative 3 plus 2 would be negative 1a or negative a. Is that the middle term we wanted? Yeah. So a plus 2 times a minus 3. Or we could have it flipped, a minus 3 times a plus 2. Questions on this here? We good with these 4 here? $16, $17, $18. Because I'd say at this point, realistically, we've seen one of each type. So I'd say at this point, if there's any specifically that y'all want to look at, let's look at those right now. $21, yes. 45x squared y minus 150xy plus 125y. Not a sum or difference of perfect cubes, not a difference of perfect squares, so we're looking at factoring. And I will always look for greatest common factor. Now, if we look at this here, well, I notice that there is a y in common with all 3, so y has to be factored out. Now, 45, 150, and 125 should have at least a greatest common factor of 5. And that's where I would start first. Because 45 divided by 5 is going to be 9. We still have the x squared, y factors out. Minus 150 divided by 5 would be 30. We still have the x, but the y factors out. Questions on this so far, how we got to this point? Now, there is something I'm noticing. I don't know if it's going to hold true, but 9 and 30 do have a common factor of 3, yes? So there might be another common factor, but we have to wait and see. Because if I divide 125 by 5, we get 25, yes? Is 25 divisible by 3? No. If it was, then I could factor the 3 out. Okay? Now it is, up to this point, we get the feeling in the way it's, a lot of times it's taught, I don't want to factor anything out until I find the greatest common factor. There's nothing wrong to divide a common factor out. Check and see, is there another one? If there is, we factor it out and go again. But since there is no other common factor, 2 sets of parentheses with 3 spaces. Third term is positive, so our signs are the same and match the sign of the middle term. Almost put plus. Should be minus and minus. Factors of 9x squared. Well, the x squared would be x and x. Factors of 9 are 1 and 9 or 3 and 3. Personally, looking at this, 30, especially compared to 9 and 25, 30 is a bigger number, but it's not so far away from 9 and 25, just factor-wise. If it was 75, 100, I would say we're farther away. So since the middle term is kind of close to our numbers, I normally start here. Now, yes, because when we were looking at, say, 100x squared and 9, we ended up having smaller numbers, but I start 3 and 3. Factors of 25. 1 and 25 or 5 and 5. Five and 5. 1 and 25 may or may not, it's not going to work here because we'd have to multiply 25 by 3. 25 times 3 is 75. Now let's check and see if we get the correct middle term. 3x times negative 5, 3 times negative 5, negative 15x. Negative 5 times 3x is going to be negative 15x minus 15x is indeed the negative 30x that we wanted. But just kind of comparing the 2 sets of factors to each other and determining that, not a set rule, it's just something I've noticed. And it's really, I'm just using it as a hint at what the first set of factors I want to try. Trying to help give me a better chance of getting it right on the first time. Even if I don't, well, here we get switching the 5 and 5 doesn't do much. Switching the 3 and 3 doesn't do much. So if this didn't work, we'd have to switch to 1 and 25 or 1 and 9. Yes. Part 1 is going to be 10 problems. Part 2 is 10 problems and a bonus. So the whole test is 20 problems with 1 bonus. So 21 total with the bonus. 24, yes. 24. So if we look at this here, we can start off with the variables. All 3 do have a in common. Yes? So a cubed, a squared, well, the smallest exponent attached to a is 1, so the most I could factor out of all 3 is just a. Now we do have b squared, b cubed, and b to the 4th. Well, the most we can factor out is b squared. Now, we need to see if 186, 9, and 117 have a common factor. Well, the biggest number we could have is 9 or 3. Just factors of 9 are 1, 3, and 9. So I'll start 186. 186 divided by 9. No. 186 divided by 3. Okay. So 3 is a possible factor as long as 117 divides by 3. It does indeed. So 3 is a common factor. So I just use the factors of 9 to get there. Does that make sense? Because greatest common factor has to be factors of all 3. 9 tells me it's only divisible by 9 and 3. 1 doesn't tell us much, so the others have to also. 186 divided by 3 we saw that 62. If I factored a out of a cubed, we're left with a squared. And if we factor b squared out of b squared, factors out completely. So we have 62a squared. 9 divided by 3 is, well, 3. If I factor an a out of a, it's factored out completely. And if I factor b squared out of b cubed, it's going to become b, and we still have c. Plus 117 divided by 3, 39. 39. If I factor an a out of a squared, we're left with a. And if I factor b squared out of b to the fourth, we're left with a squared. Now, we've done some of these. I think we've done some of these in here where we had AB. I can't remember which class. I know I did it in a few. If the first one has a squared and the last one has, say, b squared in this case, it works as long as that middle term is AB. Here, since we have that middle term with c, that shows up nowhere else. That's one thing telling me that this doesn't factor any farther. Also, the third term has AB squared. That's, again, not going to work. So this would factor farther if this had been, say, AB, and that had just been b squared, because it's going to share the middle term. Yeah, it has to be AB in the middle. But if I remember right, we won't have any that will end up in that form besides our perfect squares or perfect cubes. Difference of perfect squares or some are difference of perfect cubes. Factoring by grouping. So our 25, 26 don't show up. Yeah, factoring by grouping is not going to be there. We're not going to do our, essentially the end of lesson factoring 3. I didn't put that on the test. Let's look at 27 or 28. Doesn't matter which one you pick. So we do have a difference, yes. We do have an x squared, but it looks like there is a greatest common factor between them, yes? Because we do have an x squared, yes? Is there a number that goes into 12 and 144? 12. So I can factor a 12x squared out of both, yes? If I factor the 12 out of 12, it's going to be 1. If I factor an x squared out of x cubed, we just get x. If I divide the 12 from 144, we get 12, and the x squared factors out completely, yes? So we're trying to go from here is 12x squared times x minus 12, yes? X minus 12, x and 12, is there a greatest common factor inside that parentheses? No. What's the degree inside the parentheses? We are. Yep. 27 works the exact same way. I do have the full review video up. I posted it later yesterday. So I'll answer that here in a second. So again, if you want, go back, watch those for any that we didn't cover. And 29, a problem like 29 will be the bonus. So you're wondering how we got x squared here. So when we look at this here, we're looking for what's in common with these two. Now, both of them do have an x, yes? Now, the most of them that I can pull out is going to be the least degree of the variables. Because x cubed, x squared, I can pull 1 out of both, yes? Now, that's going to turn the x cubed down to x squared and the x squared down to just, well, they still have an x in common, yes? So I can actually not pull 1, but I can pull out 2. Because if I factor 2 out of the x to the third, I remove 2, it's going to go from x to the cube to x. If I pulled 2 out of x squared, well, we've removed both of them. So it reduces to 1. 12 times 1 is just 12. Does that make sense? So really, especially with variables, greatest common factor, I look for that term, which one, whatever the smallest degree is, smallest exponent. That tells me how many I can pull out. of that there, because if I tried to pull out 3, x to the third would simplify. But I only have 2 of them here. I can't take a third one out of it. So it kind of hints at what's going to be the greatest common factor. Does that make sense?